Okay. I will try to make this video very short. This video is about to introduce a new program, new course for Eurocode. This course is about application of Eurocode in France, and especially application of Eurocode for retaining walls. Okay, so I will try to give you a very practical case how to design a retaining wall according to Eurocode, and specifically according to the France code, France norms. So as I told you in my class of Eurocode, the program of Eurocode, despite its Eurocode, the Eurocode is for the whole European country. There are some specification for each country. Okay, so this one is application of Eurocode in France, and it concerns retaining walls. So first I will do for retaining walls, and maybe next I will do for shallow foundation, deep foundation, and so on. Yeah, but this one is especially for retaining walls. This kind of thing. The one, for example, the typical example we are seeing on this photo. Okay, so as usual, we'll do in both French and English. Okay, so if you want to learn French, you can watch both English video and French video. Okay, so let's see. I really hope you will learn something from this program, from this video, and you will try to apply. So this program has 5 chapters. Chapter 1 is general, just general things. Chapter 2 is about assumption and data input. 3 is about calculation method, justification, chapter 4, and example. In this chapter 5, I will try to take as much as possible the different type of retaining walls and try to show you how to design this retaining walls. Okay, yeah, so if you are interested, please follow this playlist till the end. Okay, chapter 1, geotech general part. This chapter has 3 points. The first one is just scope. The second one is failure mechanism of retaining walls, and the third one is limit state of what are the limit state we have to check for this retaining walls. Okay, so this video will talk only about this point, because this point is somehow very important also for you to know. Okay, this point only, scope. So you know that this French standard indication of this for design of geotechnical structure, especially retaining walls, is standard for national French national application of Eurocode 7, which is geotechnical design, geotechnical calculation. Okay, so this standard presents method for designing walls, retaining walls, that are fully applicable to category 2 of geotechnical engineering structure. So what kind of retaining wall are we talking about exactly? So these are only retaining wall that don't based on gravity, not gravity walls actually. There is another program for gravity walls also. But this one are retaining walls, not gravity walls. Okay, so it will cover the following point: continuous walls. These are like diaphragm walls, sheet pile walls, and non-uniform inertia. I will give more detail about this point later. But we have also the walls made by alternative passes. I will show you what is the meaning of this. And trench seals also. So for this one, specifically for this one, we have at least 4 types. Discontinuous walls, we have Berlin walls for this type of discontinuous wall. Mixed walls, the walls reinforced with grouts, and walls made up of a second pipe. Okay, so I will try to explain you what is the meaning of all these points. But remember, we have four type of walls. 1, 2, 3, 4. So all these 4 types. In this program, I will try to show you how to design all this. Actually, the design is standing for all these type of wall. Okay, so first, let's go for the first type, the continuous wall, diaphragm wall, and sheet pipe. This is an example of a diaphragm wall. When you want to construct basement, underground space, you need this kind of thing to retain the soil. Okay, so in this program, I will show you how to design this type of wall. There are also this type of sheet pile walls. So this sheet pile, this is example of, like, I think construction of the port in France, Havre port in 2000, and during the construction of a new, I think, K-wall, I'm not sure. So here is an example. I will just go to give more detail about this diaphragm wall. And this wall, do you recognize these two buildings? The World Trade Center, which was destroyed in 2001, okay, built in 1966, destroyed in 2001. So this photo shows the construction of this diaphragm wall during the construction of this center. Okay, this wall, the right side. See, and this one is showing a photo. So after destruction of the building, the center, I think this photo was taken in 2002. Yeah. So how this type of wall are constructed exactly? Let me show you just one example. Here we have a mechanism how this type of wall is constructed. So first we set this line. This line is like the guideline, okay, on the ground horizontally. You set, and the line will guide you to making the wall, okay. And I use this machine to dig the ground deep underground, make the hole in the ground. This machine is just like going under and grabbing the ground and bringing it out on the surface. Of course, starting from the surface, and it grabs the soil and bring it out. And you will have this space, something like this. And after that, you insert the reinforcement. You insert the reinforcement in the space made, the hole made in the ground. Okay. After that, you pour your concrete. Okay. And this is how we obtain this type of wall. Again, this course is not really about how to construct this type of retaining wall. This is just about how to design the wall. Okay. Yeah. So we have also the non-uniform inertia type of wall. So that includes, as I said, bare line walls, like discontinuous walls. So this type, as you can see, this photo is showing one example, typical example of Berlin, or Berlin, I don't know exactly, maybe Berlin walls, and how it constructed. So we just insert the walls, this after inserting in the ground by pressing, and then we dig the ground. And of course, we have to put this kind of thing as support. So once again, this program is not about how to build retaining walls, but how to design them. We have mixed walls also. This is one very typical example of mixed walls. We have here tubular pile and sheet pile mixed together to build this type of wall. We have also grout reinforced with grout. This is same procedure with what is the name? This one, sorry, let me go back. Same as this one, okay? Diaphragm wall, but using just this grout. You see the concrete is just like a liquid, and we put inside. And the same machine grabbing the soil from inside to the surface. And another one is this type of wall, the second pile. Maybe you have seen this kind of wall before. So this is just tubular piles put together side to side. Yeah. So we are going to try to know how to design this type of wall. And we have also wall made by alternative passes by alternating passes. This type of wall, okay? We can see this kind of support to support the wall and prevent it from falling, okay? And also we have this kind of trench seal when you are maybe for sanitation, this kind of thing, you can use this kind of wall. But anyway, all these type of walls are included in this program. We want to know how to design all this type. Here is just one example. For example, how this type of wall, how the effort, how the forces are. This support can help to make this retaining wall more stable. Okay, I think that's all for this first video. This first video is just to present you what we will be dealing with in the future in this program. Okay, so thank you very much and see you in the next video.